interesting, making the big data smart so you can innovate your business on your core process and also on your last but not least end users. This one then in the end comes then obviously to the success, which is quite generic. But I think it was still quite important just to give you a brief update about what kind of factors are important for big data. The platform was mentioned before from Mr. Greenway. So you mentioned the platform. And I think the platform is very important because you don't only need to be able to analyze the data, but you also need the security aspect. And what I will show you here, sorry that I'm just flicking through, usually this takes a while, is that I will show you now the platform, what we basically, and also other companies are seeing here. So in terms of the platform, I'll just make it bigger now. It's basically that we have here on the top the user experience. The user experience we talk about when you want to engage with your end users. Big data is not only about preparing data for your lines of business, for marketing, for sales. Big data is also about enabling of the end user so that you're able to create your own report, adapt certain aspects according to your business role. So the user experience is very important as a first step. And not only that, we also talk about here, as I said before, about the analytical part. So that's the reason why also Mr. Greenway mentioned before in terms of roles. Obviously, the consulting companies are quite keen on the data scientists. These are usually, I always call them crazy PhD students or crazy PhDs who actually like to really get their head around the data and making the data smart. So this role definitely becomes more important also for the government. Especially in banks, they have really strong big data science departments already, but in other industries, it's still lacking. So look into this knowledge either by asking providers who have predefined industry-specific analytical tools available, or, as I said, look into data science colleagues who are able to run it. What was also mentioned were existing solutions, you know the ERP solutions or HR solutions to make, for instance, a travel request. Obviously, these stay the same, but the important part is that these solutions can also be in the end in the cloud. This was also mentioned before. Cloud solutions are coming much more important. I would say in the German-speaking countries they're quite still a bit more skeptical, but in France, I have also in Kazakhstan, also or in US, cloud solutions are actually quite common now, and maybe in the future overtaking the on-premise solutions. So I think here renting a software is definitely a nice business model, depending obviously on the security aspects. Nevertheless, US being maybe in the government area, also have here homegrown self-development solutions, and they should definitely stay. It doesn't mean it's a rip and replace strategy, you should definitely stay with them. However, without the platform, you need a strong, let's say, I always call it heartbeat. And the heartbeat is at the end, basically, we always call it, in our case, we call it HANA. It's basically a new database which enables you to store the data in memory, and this enables you to analyze the data in real time. Let me give you an example. For instance, I will show you later on a football soccer case where our World Cup team, this might be one reason why we won, was able to analyze the players before and after the game. And each game generates around 40 million data hits. And it took around 5 to 6 hours before to analyze the data, so the distance, the ball positions, and so on. And now with this new platform, it takes 4 to 5 seconds. And this is what we mean here with in-memory database technologies. Obviously, there are also other competitors who are offering them, but in this case, this is definitely a new technological change that we're actually able to define and calculate this data in real time. Yeah, so before that, 4 or 5 years ago, that was not even possible because we couldn't tell the trainer of the German football soccer team, you need to wait 5 to 6 hours. And if you told us that he wants to analyze 100 games, then the World Cup is already over. So that was not feasible. Or we couldn't tell the CIO or the CFO, you need to wait for your report maybe 2 weeks because you have so many data in your supply chain. And then the CFO was like, sorry, but that's way too late. So we need it in real time, or at least within a much faster way. So this was actually all about, the topic about the platform concept, which is important. The big data topic is such. Let me just show you some examples what we have defined. Um, so in terms of the examples, I will just show you two examples. So one example, I think it's a very nice one. So don't worry when I look always a bit around there because I didn't share the screen now, but don't worry. So what you can basically see here is called natural catastrophe planning. And what we have developed here is, especially for the government and insurance industry, very feasible because we would like to help when a hurricane arises, or storm, or flooding, or fire, to predict what kind of incident this natural catastrophe would occur in a certain region. So what does it mean? We were collecting geographical data from certain hurricanes or floodings, and we analyze this data with certain households who have a certain insurance, for instance, against flooding in this area. And then when you look into the next slides, you can basically see that this now is basically the hurricane which is moving here now from the south side of the US more to the east side. Yeah? And this is something which was very relevant for the insurance and also for the governmental industries because they would like to predict if a certain hurricane might maybe move first earlier to the shore or later. Because what you can do then is the next step is you can look into the certain bubbles, and these are certain insurance areas, and can analyze what kind of impact and what kind of cost would occur for certain insurances. This was obviously not, I would say, new for the insurance industry. What is new here is that we were able to analyze this data in real time. So next time when a hurricane occurs in the US, we're able to use the geographical data information. We can map them with the households, with the contracts they have for insurance, and then we can make certain predictions. If the hurricane hits to New York, or if the hurricane hits to Boston, what kind of cost would occur? And insurance, as a next step, can actually beforehand inform certain construction companies and reserve them so they're able to clarify the plan earlier. So it's all something about reputation. And this is obviously also very interesting for countries where you have maybe fires or natural catastrophes, so that you're actually able to react faster. What is here big data? You ask, why is it so interesting? So I'll just give you some numbers. If you're talking about 40 million data records, which is households, contracts, plus the geographical data. It took before, with the normal solutions, about, it wasn't possible to calculate in real time. If you would like to do it in, let's say, more or less real time, it took you about 1 to, let's say, 60 to 90 minutes. And now with the new platform, it's just you can do it in real time. So this is a nice example of how you can make use of big data in a real-time setting. Another strategy was discussed before, which was about, I think the colleague from the telecommunication industry, and I think also you and also Mr. Ibaraki was talking about the traffic jams. Traffic jams, I know you know it yourself, depending where you are and where you're driving, it's always being rushed or also annoying. So what we have developed here, this is now a proof of concept we're doing with a big car corporation in Germany, and also a car manufacturer, and also a car distributor, and also with a rental agency. We're basically analyzing and using the GPS data. So when you look at the red spots, these are single cars who are showing certain signals. So we're making use of the GPS data. And obviously it doesn't really make sense to have a really holistic view because you can't do anything with it. So what you need to do is you have to provide a dashboard. The dashboard also based on the platform, and then in the dashboard you see on the left side the different car models and also where they're located and what kind of problems they have. Yeah? And then you have some statistical figures like fuel efficiency, how many kilometers the car is driving. So basically a dashboard about the car. And these data are anyway generated in the car, so don't worry about it. As long as you have a GPS system, these data will be generated, but they're usually not really used as a service. And what the nice part here is that we're making use of GPS data, and obviously when you have only one car, you can't improve the service. But if you talk about many cars, what the car manufacturers are looking for, then you can increase the service. Specifically, also relevant for car sharing concepts. I've seen here in Kazakhstan also the bike sharing concept, so that's not far away. but also for the logistic industry. Let's say in our case, the Deutsche Post DHL, the biggest German logistic provider, would like to understand where the trucks are actually driving, so they can dispatch and reduce the standing times of the trucks and then improve the service. Chemical companies are using it because they would like to know what kind of goods are the trucks delivering from A to B, and would like to reduce the standing times because standing costs a lot. If a truck is standing for a few hours, it's not as efficient as it would arrive at the destination, unloads the good, and drives off again. The next example is police cars for security. Police cars and also for hospitals are going to use this technology to understand where the current police cars are dispatched, so they're actually able to react fast on certain incidents. So it's a nice use case what we are currently realizing. And two more actually I forgot is about car rentals, because car rentals would like to know what kind of brands are driven how, so they can actually approach the insurance companies to tell them, look, this car, for instance, a Golf 3, doesn't have many accidents, so I would like to reduce the car insurance of the specific brand. So there are many nice areas which you can look into. And I would say last but not least, a nice example is also here in this respect is pay as you drive. This is done by the Zurich Insurance. The Zurich Insurance offers drivers to put in a GPS sensor in their car, and depending how they drive, if they drive more efficient, the car insurance will be reduced per year. This is all already done with a similar technology. So I think, big data is actually feasible, it's already out there. You just have to look for the right use cases and actually just grab for the opportunity. The last, how much time do I have left actually? How much time do I have left? How much? 20 minutes. So basically, I mentioned, as I said before, I mentioned several things about different devices and what you can use. And obviously, it doesn't really make sense to talk about it without showing it to you. So two more maybe showcases I would like to show you. This is now with the applications. And as I said before, you should make the experience for the end user as feasible as possible. And what we hear, this is now we call it a proof of concept with similar technology in terms of understanding where the police cars are going. This is now a demo just, so because this is not live. The other two demos were live. And this basically shows you a similar approach. You've got the map. You basically know what kind of incidents are occurring from the police cars. And then you can basically accept a certain order as a driver. And what is actually quite nice is then you know what's the distance, how long does it take to reach the goal. And then when you reach the site, because there was a certain incident, you can make certain, you can use new technologies. For instance, fingerprint verification here with the camera technology. Then you can have, for instance, ear recordings, so you know basically who the person is. You can look at the details, okay, what's the name, but you also know the evidence of the background, so what actually happened before. So she was a shoplifter, she was speeding, she was quite fast. And this is actually something, when you then create a new incident report, you can basically here then create a new incident report and define certain aspects. Obviously, as I said before, this is like a visionary approach. You're looking here with the German police station to realize this, because they would like to use latest technologies and also actually having the records always at hand without always calling the central station, police station. What you can also do then is you can, for instance, create a new incident, which is always quite nice because maybe there was a new problem now, and then you can basically here save it. And for instance, as a witness report, for instance, you can take just a picture of the certain location. You see who looks not so happy now. Okay, so where the airport guy. And then you can take a picture of the person and use the photo as an instant report. Yeah, so I think it's quite nice to see what you can do now with big data actually, because it's not always about big data, it's about how to make it and put it in the right context. The last showcase why, okay, now I'm in Kazakhstan, but I'm still going to say why Germany won the World Cup is because that we were supporting the German national team in player performance evaluations. This is not a showcase, this is a real product from SAP. Obviously, I can only show you now like a demo like this. And what this is about, it's basically about we would like to understand each player performance and also analyze each game. So player performance and game evaluation. And what nice is, as you can see here, you have certain frequencies. At the top side, you can see basically parts about player statistics, for instance, pass completion rate. So this is basically up there. It's the pass completion rate. You also have other aspects like success passes, but also in relation to your other team you're playing. At the top here, you can basically see some statistic like the distance to the other players, but also the defense line. And this is basically when we talk about statistical evaluations. You can see the defense line, how the players playing against each other, and how strong was the defense line. And this is, you can drill down to each player itself. And for the World Cup, the German national team used it to create a report like this for each player. So each player was after the game possible to have a look like this. So they had on the bottom the certain sequences that could basically look what kind of sequence they would like and would basically analyze. And they have the capability to make these evaluations about defense shadow, the defense line, and also how you can actually stand next to your other players. Yeah, it's nice because it's real, but I think the nicest part is here, why is it big data again? Yeah, so the same question. Big data is because we're using the same platform. User experience, like here, we needed a tool that the trainer and the players like to watch. User experience. Yeah, analytical capabilities are coming here into the game when we have the certain statistics with the defense shadow, because we needed to define what is a defense shadow, what does it really mean. This is the analytical part. And then obviously the engine, the heart, in this case it was SAP HANA, where you can make a real-time evaluation. What does real-time mean? As I said before, 40 million data records per game recorded. It took before 5 to 6 hours for the evaluation. Now it takes 2 to 4 seconds. And I think big data then comes into place when you only evaluate one game, but when you evaluate 50 or 100 games, it was a requirement of the national team. They would like to evaluate at least 50 games, but not from each own player, but also from the competition. They would also like to evaluate each player from the competition and basically make a pre-definition in a strategy planning what kind of strategy should be played for each game. And for the training as such, maybe that's also quite important. For the training as such, the players are wearing sensors. So each player has a sensor, and also in the football there's a sensor, and there the data are recorded in real time and shown to the trainer in real time on their iPad. And this becomes interesting when we talk about wearables and when we talk about healthcare, because we also are getting the biometric data, the pulse, the heartbeat, and so on. And this is basically compared in a statistical evaluation and then also suggested to the trainer when each player should be basically started for each game. So when you include also the biometric data, this was the example our colleague was giving before. I don't want to have a heart attack and basically be dead. I actually want to get informed from the system, from my wearable device, from the doctor, that I might get a heart attack in 2 days, and that's the reason I should rather go to the doctor 2 days earlier before it's too late. So these are actually the prediction part which comes into place when we talk about the big data. And here, as I said before, this is nicely done because currently 2 other clubs in Germany, so I think you know maybe Bayern Munich, still know, more or less, yeah. So they're using it now, and it's good for the championship. And also I always call it the SAP club, it's called TSG Hoffenheim, which is based next to Waldorf, where our headquarters is. They're also using this technology for the practice and for the games. Maybe because you're looking quite interested now, I can see, probably ask yourself now, but how in the real game are the data actually be collected? Yeah, it's very easy. How are the data collected? And in the real game, it's not allowed to wear sensors. It would be great, you know, when you would be allowed to wear sensors during the real game, then probably the betting mafia would, you know, probably super rich now and wouldn't work anymore at SAP because they already know how the game would end. So during the real game, the camera is recording the full picture of the game, and then basically the picture will be transferred into a digital format. Yeah, so this is for the real games. And the nice part is that we are also able to digitalize not only our games but also the games of the competition, also of the other countries. And this, as I said, for the training you wear sensors, and for the real game you basically record the game. So for the last summary, this is also the last slide I would like to show you now. It's basically the last summary. What does big data mean? Where do we get? How do we get there? I showed you the various parts. So big data is not just about big data, it's about real-time prediction in the right context. So in terms of e-governance, look into Expo, look into creating services so that the end users or even the tourists are getting the real-time information. But also, for instance, G-Cloud offering, not even 500 e-government services, but even further services in terms of fraud, in terms of improvement of security, in terms of creating better healthcare services. The user experience, as I said before, is important because not everyone would like to access a laptop or a PC. They would rather like to use maybe a mobile device or even the smartphone to get the right data in the right context. So the user experience is also at SAP extremely important because the people who know SAP, who know the existing systems, are probably a bit worried because they're not that, I would say, nice and smart. They're rather, I would say, a bit more boring. Yeah. So with the new interfaces, we are here obviously using latest technologies. We call it HTML5. It's a common industry standard where we're basically able to create applications or websites where the use case and the process can be shown. Important is also the application and also the analytical part, because without making the data smart, you don't actually have to start with big data, because then you have only a lot of massive data, but they don't make any sense to you. So look into the details, into the end-to-end process of making big data smart. And obviously, last but not least, the deployment part. Deployment, that's the reason you have to think about security, where to store the data in the cloud. Obviously, this is always an ongoing issue in Kazakhstan, maybe in Russia, or definitely not, I would say, in the US. So look into the deployment options, but also look into the aspect whom to invest, so where and which provider do you actually trust. And there I would say definitely go for the providers who are having a platform in place, not only a fast database, an in-memory database, but who are able to provide you the full scope, the experience, the analytical part, the database, and also, last but not least, the trusted information, so that you basically are able to innovate in the future, not only once you have put your data into a big data context. One recommendation for the governments, this is my last part, what I would say, how they should start. Don't start always big, start with small co-innovation projects. They usually last between 5 to 6 months. You choose a certain use case which is relevant for you. We always call it design thinking. Design thinking is that you choose basically for your industry 5 to 4 use cases, and then you make a rapid deployment and show, is it actually feasible? Yeah. You don't have to buy HANA immediately. You can just basically rent it and see, does it really make sense for this specific use case and process? Does it really make an improvement for you or not? So start small, and then obviously then you can innovate step by step by also using the platform for further processes and for further use cases. And that was everything from my side. I think from the timing it looks fairly good. So thank you very much for your attention. If you have further questions, as I said, if you didn't like the talk, don't come to me. If you like the talk, don't also come to me. Go to my 3 colleagues over there. You can also ask me any further questions, but feel free to come. Thank you very much.
So we're running a little bit tight for time, so there's time for maybe one last comment and question per speaker, and then we'll close off and everybody can have coffee. So we'll start with Damir Shenevekov, and you have an amazing university, IT University, Kazakhstan's first IT university, really a Central Asian leader, and highly skilled, internationally recognized IT experts in the region. Can you maybe just give us a few ideas in terms of where you want to go in the next year, perhaps?
So, nowadays I'm proud to say that IT University is a real center of IT innovations in Kazakhstan, especially in academic program. I think it was a great job of our staff and students' achievements. And these 3 years to our strategy is to improve the scientific research center in IT. And now we're creating the several laboratories, especially in big data, cloud computing, and other scientific researchers. And we're attracting the best scientists from other universities, from Kazakhstan and abroad. And after this future 3 years, we want to increase the number of our international contracts and agreements with universities and vendors, famous vendors in the world. So now we have, as I said before, different laboratories with the education of famous vendors like Apple, Training Center, SAP, Commercial Center, Oracle, Microsoft, Cisco, but now we want to certify all of them and to create a real center of education in Kazakhstan.
Thank you. That's a really interesting journey. You're taking the university